Okay, so here we have our plant setup, our moisture sensor, pump, all of our hardware. We have our live graph here. We're being prompted to adjust the potentiometer for the size of the plant. The larger the plant, the larger the size, the longer it will be watered for. All right, we're gonna press enter, and then we're gonna see that our pump has started. It's filling up the water, and we see a difference in our live graph. We're also gonna be able to see that with the press of our emergency button, we shut off the system. So the live graph stops updating and the board is disconnected. To fulfill CLO 1, unit testing was done to ensure that moisture values, which previously went up to 1023, were being properly converted to voltage values that went up to 5 volts before graphing. This was done by testing a series of random moisture values, including ones on boundaries, which were converted using thresholds to the correct voltage values. For CLO 2, I used to have all of my code in a mains file, but then I included it to be across multiple files. I also used polymorphism, as you can see, in the overriding of on value change in my OLED class and in the use of private variables in my OLED class. For CLO 3, the API used for graphing was java.swing, which uses JFrame and JPanel to provide a live graph. For Modo4j is the API being used to handle all the hardware. For CLO 4, the converted moisture values are being stored in an array list as doubles before being graphed. For CLO number 5, the watering is controlled by a state machine. One of the events that the state machine looks for is the button as an emergency stop, and it also functions using a boolean from whether or not the pump is running. For CLO 6, one problem that I encountered was that my button was not being listened to properly, which I fixed by introducing separate threads in my OLED and my buttons so that each could be running at the exact same time.